Hi everyone, welcome to this video on standard deviation. Just as a reminder, we've been talking about measures of center in class, and in this video we are going to be moving on into measures of variance. Now we've already talked about the median and how we look at we're talking about the median as a measure of center, we also look at the interquartile range, or that middle 50%, which is sort of that typical value. Okay. And then we've also looked at the mean, which is the average. Most of you are fairly comfortable with that. But when we talk about mean, we don't look at the interquartile range. Instead, we look at the standard deviation, which has to do with that spread. So remember, the median was that physical middle, and then this was the physical middle, whereas the interquartile range then looked at not the physical middle, but the 25th percentile spot and the 75th percentile, getting us that middle 50%. So this median in IQR is all about positioning. Where is the data in it if you put it in increasing order. Mean, on the other hand, was all sort of about weight and how far out the actual values of the numbers are, and that sort of idea of balancing. So let's take a look at a little bit of data. So I have two students, Andrea and Ben, and I'm going to keep the data very small so that it's a little easier to take a look at. But let's say Andrea and Ben are two of my students. They've taken 3 exams, and Andrea's 3 exam scores in chronological order are she earned a 79, an 80, and an 81. Actually, these are in numerical order, not chronological order. 58 for Ben. Then he earned an 85, and then he earned, one of his exams was a 97. So just by glancing at this data, we can see that Ben's scores are much more spread out than Andrea. But let's go ahead and talk about what is going on with these two and take a look at what is the standard deviation. So what we've been doing in class is, if we do a dot plot here for Andrea's data, we know that she scored 180, she scored a 79, and she scored an 81. And the average distance from the mean was this. She had a +1 on this side. 81 is 1 above the mean. And here's the mean right here. And she had one test score below at 79, that's -1. And then one of her test scores was right on the mean, 0 distance. So we can see that -1 plus +1 equals 0. So that mean is that point of balance. Let's take a look at the spread over here from Ben. Ben, on the other hand, he scored, let me just do this here. Let's do 60, 70, oops, 70, 80, 90, 100. And now for Ben, he scored an 85 on one of his tests. He scored a 97 on the other, and one of his tests was a 58. So if I go ahead and I draw the mean right here at 80, which is not exactly one of the exact test scores, is that balancing point. We can see that by taking a look at the distances. So from 80 to 85 is a +5. Okay, and from 80 all the way out here to his 97, that's +17, giving us a total of +22 on this side. And as we can see from the other side, from 80 all the way down to 58, 58 minus 80 gives us that -22. So we can see that this is balanced too. But these numbers, 22 on that side and -22 on this side, versus a 1 and a -1, there's much more spread over here with Ben. Okay, so if we looked at interquartile range, which is tough with only 3 pieces of data, we can see that his interquartile range would be much more spread. Okay, how do we find the standard deviation and what does it mean? Okay, I've created a couple of tables on this um, oops, on this one that may look a little overwhelming at first, but let's just talk about a few things. So this first table here, this right here is our X values. So right here I'm just going to write Andrea's 3 test scores, 79, 80, and 81. Okay. Now, the first thing we need to do before we can find the standard deviation is we do need to find the mean. What is her mean score? And we can draw a line here. And that's where this is coming from right here. When you see a bar over the X, that means the mean of your set of X's. Okay, and this sigma sign, which is a Greek letter, all that means is sum. Add them up, which is addition. Just add everything up. So if I sum up X in this column, all that means is add 79 to 80 to 81, which gives me a sum of sorry there, um, 240, right? Gives us a sum of 240. So all that means is this fancy little symbol here means the sum of my X variables, which is 240. So if I come down here and I want to find the mean, all the mean of X is equal to the sum of X, which was 240, divided by N. And N is always your number of data points. And that's up here, N equals 3. Andrea took 3 tests. So 240 divided by 3 is equal to 80, which we got on the earlier page. So now we know the mean is 80. Okay. In this next column, what we're going to do is we're going to find that distance away from the mean, just what we did on the earlier page with the lines and the dot plot. So here we would say 79 minus that mean. So I'm just looking at X minus the mean, 80, is equal to a -1, which is just what we got on the other page. This next one, 80 minus 80 is 0, and then 81 minus 80 is just 1. And if you were to sum up this column right here, you would get 0. But we're not going to do that right now. We don't need to do that. So if these numbers are always going to add up to 0, it doesn't help us very much understanding the spread. So what we really need to do is, if we're looking at spread, we need to get rid of these negative signs, because the distance, it's really about the distance. The negative just means it's below rather than above the mean. So if I take that -1 and I square it, that's the same as -1 times -1, which is a +1. All right. Why do I do this? So that I can get rid of all those negative signs, because I'm focusing on the distance. 0 squared is just 0. And 1 squared is just 1. Okay. Now what I need to do is I'm going to sum this column. So the sum of these X minus the means squared, all of that fancy stuff, is just 1 plus 0 plus 1, which is 2. Okay. Then I'm going to come over here. This is the formula for the standard deviation. That's all this is standard deviation. It's just a formula that's going to give us a number. Okay. So what is the standard deviation? Well, this first numerator here is exactly what we did over here. So for this is our 2, okay? And divided by, now over here we actually take n minus 1. So we know n is 3. We subtract 1, which is 2. And then we are going to square root that. And the reason we do that is because over here we squared all of our values. So we need to square them to get them back to the right size. All right, and then this 2 divided by 2 is just 1, so we end up with the square root of 1, and that's just 1. So the standard deviation for Andrea is 1 point. Right, we'll get to that in a little bit. So her mean is 80, and her standard deviation is 1 point. That means her average test score was 80 points with a standard deviation, sort of a spread of just 1 point, and that makes sense. Look at her tests. They're all about 1 point away. Yep. So that would make sense that a standard deviation for her is 1 point. Okay. If you want, you can pause this and we'll take a second and do find Ben's standard deviation. Okay, so let's look at Ben's scores in purple. He got a 58, an 85, and a 97. And if I add those up, if I sum up those X's, I get 240. And then if we bring Ben down here and we substitute into the mean formula for him, which we all already know, but it's the sum of our X's, which is 240, divided by N, which is also 3. Ben also took 3 exams. So that hasn't changed. N equals 240. 240 divided by 3 is 80. So Ben has the same exact mean as Andrea, which we know from the previous page. He has the same mean. So just write that up here. Ben's mean is 80 points. Average test score was an 80. Okay, let's fill out this next column. So what each test score minus that mean. We're trying to find that spread, which also we did before on that dot plot. So 58 minus 80 gives us that negative 22. Should have made it a little bigger. 85 minus 80 was a positive 5, and then the 97 minus 80 gives us a positive 17. So again, you can see that those sum up to 0, which is what we want. We know that way we can confirm that 80 is the mean. Now let's square these numbers. We're going to get some much bigger numbers here, much bigger spread. That negative 22 squared is equal to 484. And all of this you can do right on your calculators. 5 squared is 25, and 17 squared is 289. So now what I want to do is I want to sum up this column. It is the numerator of my standard deviation formula. So the numerator of x minus the mean, all of that squared is equal to, and you can put it on your calculator, but is equal to 798. Okay. Now I'm going to just right here, running out of space, but I'm going to now plug this into the standard deviation formula, which is this numerator, the 798, divided by n minus 1, which is again 2, because we have 3 data points. Minus 1 is 2. When you do that on your calculator, you get, remember to do the division first. 798 divided by 2 is 399. And then you square root that 399, and you're going to get 19.97 points, which I'm going to round up to 20. I'm going to take it up here, and I'm going to say that Ben has a mean of 80 points, but a standard deviation of 20 points. That means that it's much more common for him to have a range of 20 points than whereas Andrea only had that range of 1 point. So we can just see by looking at these numbers without even knowing the actual data points that Ben's data is much more spread out. All right. So how do we use this information, and what does it mean? Okay, so you remember from the median and the interquartile range that a typical value when you're looking at the median is the interquartile range. For mean and standard deviation, it's a little bit different. Now what we have is a typical value. Typical value is now going to be equal to the mean plus or minus 1 standard deviation. 1 standard deviation. So what does that mean for someone like Andrea? So let's say I was going to give a fourth test, and I asked the question, would it be unusual for Ben and Andrea and Ben, to get a 95 on the next test? You can probably guess that yes, it's probably not too unlikely for Ben, but for Andrea, maybe not as likely. But in terms of statistics, let's take a look at that. So for Andrea, what is her typical test range value? Well, it is the standard deviation, which for her is 80. So it's going to be 80 plus 1 standard deviation. It should be on pink here. plus 1 standard deviation, and 1 standard deviation for Andrea is 1 point. And that's going to take a little while to get that concept down. And we're also, so that's the upper limit. So we're going to do this typical range here. So she could get anything between an 81 and 1 standard deviation minus that one standard deviation, which is 1 point for her, which equals 79. This one was 81. So a typical exam for her lies in this range. This is her typical value, her typical spread for Andrea. All right. How does that differ for Ben? Well, let's take a look here. Ben's typical value is going to be, again, it's going to be the standard deviation, the mean plus or minus 1 standard deviation. But now for Ben, 1 standard deviation is 20 points. Okay, so it can be a little bit confusing, but you said a standard deviation is 20. Yes, it is. That's what 1 standard deviation is. Okay, so Ben's typical score would be 80 minus 1 standard deviation of 20 points, which would equal 60 points. So you're dealing in the same units. And the upper limit for him would be his standard deviation, or his mean, plus that 1 standard deviation of 20 points, which is 100 points. So it wouldn't be unusual at all for Ben to get a 95, because 95 falls within his typical range, right? 95 could be in here, but 95 is not in here. It would be very unusual for Andrea to get a 95. So that's how standard deviation works. Try some problems. Good luck, and we'll talk about calculators in class.